going to record those. This is Revit 2023, and when we create a new Revit model, here we have to select the template. So there are different ways to do this. You see that we have the construction template. Well, first we have imperial or metric. We have the imperial construction, architectural, structural, and systems template. We are going to work with systems, okay? So let's click on imperial systems template, and let's see what it happens. What happens? Nothing happens. So basically, we have the same screen, and you can select walls. And you can create walls as we did in Revit. If we look at the elevation, so we have elevations with levels. Okay, so nothing has changed apparently. Let's click on Analyze. And okay, so you don't have here anything that says solar analysis or something like that. There is no solar analysis on the right-hand part of the screen, no solar analysis. We have to install it. If you have taken 360, you remember that we use this, you remember that there was a solar analysis and we use that. We don't have it here yet, okay? So it's something that we have to install. So I will talk to IT guys and they have to install it. But we do have this energy optimization, so we can change location, and here we can have a system analysis. So you remember this from last semester. Okay, so we can use this at least. And we have spaces and all that stuff. Okay, and when we click, okay, so that's interesting. Look at this. If we're in the mechanical template, you can create a wall, but then you can select it. So are you all on the same page? Okay, so we create a wall, but we can select it. So here we have a template. So at the beginning, we can define what template we are working with. In this case, we have selected systems, and that's interesting because we can model things. But once we have done this, we can select the walls. This is because this template is there to design systems. Usually we create a building using the architectural or the construction template, and then we open the mechanical template to design the systems. Another thing, if you go to the systems, we are in architecture. If you go to systems and you try to, you click on mechanical equipment, what do we have here? We have a radiator. We have, do you have this by default? All this stuff? You have this in the computer? Yes. Okay. So because we are in this systems template, probably if we had opened an architectural template, we wouldn't have this. Is it, well, here we have the air handling unit, a small one, and it's vertical. We have boiler standard, we have expansion tanks, we have circulators, and we have variable air volume units. Well, it's not enough, okay? So by default, we have this, and remember that we can't, even if we want to change the height of these walls, we can't, because we can't edit the wall, because this is just to work with the mechanical equipment. If you're in a plan and you select mechanical equipment and you place this, the air handling unit, number 10, you see that we can have an element here. Okay, so if you select this element, there is a lot of information. This is an active object. It's not something that sometimes, especially with toilets or with sinks, we have two different things. We have the architectural, and then we have the mechanical, the MEP, mechanical and electrical and plumbing. I think this, the MEP stands for mechanical, electrical, and plumbing. So it's an active object. So when you go to insert and you load family, we can't do anything here. So we don't have the families here. Do you see the do you see mechanical or you see something like this? Okay, so if it were installed, it's not. We will find here everything, mechanical systems, structural, windows, furniture. So there will be a lot of folders and we don't have it, okay, because it's not installed yet. So this is what I wanted to check today. We don't have a lot of things, but it doesn't matter because today we're not going to work with this. Next week we will. And today I just want you to select this. And if we select this, you see that we have a lot of information here. We have information about when we have a square like this, it's a duct. So if you hover your mouse here, you see that you can create a duct. So we have a duct here and we have a duct there, create duct. This is in and this is out. Okay, important. So if this is in, means that this is an inlet, so the air goes in this direction. If this is out, it's an outlet, the air goes in the other direction. And what happens if I right click here, right click on this, draw duct, we draw duct. Oh, beautiful. Then if we do this, we see that we have created a duct. Okay. What happens if we right click here in this out, draw duct? What happens? No, the root solution was found. Why is that? Go to the 3D view. So you see that this duct goes upwards. Okay, so this goes horizontally, but this goes vertically. So what do we have to do? We can either right click here, draw duct, but then we have to change the elevation. So in this elevation, you see that we have here 4 inches and no, 4 feet and 9 whatever. Let's type 20 feet. 20 feet. And then click here. And we can't see this because we are at a different level, but we have created a duct like this. Okay, so when we have an object and it has a vertical outlet or inlet or whatever, if we want to create something first, we have to change the elevation and then we can go horizontally. So do you all have something like this? What else? If we select the object again, we have electric information. Okay, so this is number 2, 240 volts, and this is 14,400 VA. This is volts, amperes. We will talk about this in electrical systems. So far we're not going to use electricity, but this is where the plug is. Okay, so we need to plug this into a socket somewhere. And here we have different information. You see that we have out 3/4. When we have this symbol here, this it's something like this. This is drainage. Okay. So if we click here, right click, draw pipe. We are not drawing ducts. Ducts are for air, pipes are for water or fluids. So if we do something like this, on the 3D view, do we have, yep, so we have something here. But we have more things. So this symbol is the drainage. So that means that in this machine, we can have water and we have to get rid of it. And this is something that happens in these mechanical systems when we have air handling units or even when we have split units or heat pumps. water can condensate inside the unit, and we have to get rid of it. We have to, so we need a drain, and we have to remove the water from the machine outside. And then we will have to connect this with something else. So far, we have to remove the water from here. So we have two air ducts, inlet and outlet. We have a drain. The drain is always outlet. We don't have an inlet of for drainage. We have to remove water and everything that comes with the water. So there's no point in having an inlet. So it's always outlet. But for the fluid, there should be so you see that here we can't here and on the looking at the level or the plan, we see the outlet, but if we look at the 3D view, here you can see outlet and inlet. They are very close to each other, but here we have two active points. So this one is outlet and this one is inlet. So again, if we right click here, if we draw pipe, this would be the inlet or the outlet. This is out, okay? And if we come here, draw pipe, this is in. And Revit is good enough because when we create this, it generates an elbow by default. If we make this detail fine, well, we can see more details. And if you click here with thin lines, we'll see, I think it's better. Okay, so here we can see that we have an elbow. We can define the material. If we select this duct or this pipe, here the material is PVC, DWB. I don't know what this stands for. PVC, it's plastic. Okay, so it's a pipe made of plastic. And here we have standard. So what's the difference between the standard? Okay, so we have different things here. By default, we have this PVC, whatever. So we can change here but we have only 3 options. We might have a lot of options here. And what else can we change from this? This is the vertical justification. It's a mechanical pipe segment. Okay, so it's a polyvinyl chloride. So this is what PVC stands for, polyvinyl chloride. It's plastic. The diameter is 1/2 inch. And we have the mechanical flow. So we can change the mechanical flow, the flow of the water or the fluid that goes through it. Okay, so when we are working with this system, with this mechanical template, we have a lot of information about mechanical stuff. So we can either upload a systems template, but here you see that we are working with disciplines. Okay, so in this case, we are working with the discipline mechanical. Let's change this and change to architectural. If we change to the architectural discipline, suddenly the walls are active, and then we can change the walls. Okay, so if we're working in a mechanical discipline, the walls are not active, and the only thing we can select is the mechanical stuff. This is very convenient because when we're working with the mechanical, we don't want to change. So by default, if I select things and I move something and I'm moving walls or roofs or whatever, it's a mess. So when we are working with mechanical elements, we should work in this mechanical discipline because it doesn't, what we do doesn't affect the architecture. So that's the right way to approach to this stuff. Okay, but if we need to change a wall, so we can always switch to the architectural discipline, and then we can remove this wall if we don't want it, and then we can go back to the mechanical. Okay, But what we are going to do, because I don't want you to spend time or to waste time on modeling the building itself. So I'm going to give you different models, different building models, and you are going to work in the mechanical discipline. So you don't have to change the architecture. And that's the challenge. Because designing a building, it's something very complicated. In design courses, you design the building, so you have a client or you have an instructor, and you have requirements, you have a site, and you have to start making decisions. And when you think you are done with the building, no, this is where everything starts. Okay, so when you're okay, I'm done with the design. My building is beautiful. This is what I wanted to do. My instructor is very happy. So what do you do now? You have to start designing the real stuff. And what's the real stuff? Structures and systems. And if you don't do it, you send your Revit file to another company, a structural engineer or mechanical engineer company, and they receive your file. Probably they will receive your file. They will open a mechanical discipline. They won't touch your project, but they will give you back the file with all the systems on it, and they will let you know, okay, do you see this wall? Yeah, so it can be here. So you have to move it. Do you see this floor? Yeah, you need a hole here. And by the way, you need a mechanical room. And the mechanical room has to be 20 by 20. What? So this is what happens. Okay. They don't change your architecture, but they give you the mechanical template. And if something like this happens, what's this? Okay, so we have a duct that goes through this wall. So you have to do something for this wall. If there's a roof here and we have a vertical duct that goes all the way up, we have to open a hole on this, on the roof or whatever. And that affects the design, because if we open a hole in the roof, what about the waterproofing? What about the thermal insulation? What about all these things? So we have to rethink the project again. With the structures, it's the same. So imagine that someone tells you, oh, no, we need a column right here. Right here, yes. No, it's impossible, because here we have the projector and we have the spring. Okay. Can you place the column in there? Yeah, but if we place the column there, then you have to do a thicker slab, because the span is larger. So designing, it's always something that you have to go back and forth. If you don't know anything about structures, if you don't know anything about systems, you will suffer a lot, because when you get the project back from those structural mechanical engineers, you will have to make a lot of changes. If you have any idea of systems, if you have any idea about the thickness of this duct, you can foresee, okay, so how much space do I need from here until the structural element? I need 3 feet. Okay, so I design 3 feet. It's not just, okay, I have all this, and you get the file back from the other company. No, you need 3 feet. So all your floor plans should be 3 feet taller. What? 3 feet times 10 floors. So that means that I need 30 feet more for my building. It's impossible, because the building codes, they limit the height of the building in this part of the city. Okay, so remove 2 floors. No? 2 floors. Yeah, so these kind of things happen. Okay, so as we need to at least use this. We need to make basic calculations, because if this duct is 1 foot or 1 foot and 1 inch or 11 inches, it's not relevant. It's about, okay, it's something like this. I need something like this. It can be 2 feet or 2 feet and 2 inches. So if you make a mistake of 2 inches, doesn't matter. If you make a mistake of 2 feet, it matters. Okay, so this is why we are designing these kind of things. Is it a professional design? Not yet, because we are not taking into account a lot of things. But at least you don't have bad surprises if you're able to do this beforehand, before sending your file, your design file, to the mechanical company. There will be things that you will have to change for sure, but at least you don't have to remove 2 floors of your building, or you don't have to make your building 30 feet longer or wider, because you know what it takes first. And as you can see, pipes are not relevant. This is the size of pipes, but ducts are a nightmare. So with this, we can just tell the difference between the air ducts and the fluid pipes. So that's the difference. And remember that we can, anytime we can switch from mechanical to architectural. Okay, so if you are doing this and you notice that, okay, I have to change the architecture, there is no way to do this without changing the architecture, without moving walls, without moving floor, or without moving the roof, then you can do it. Okay, so again, it's designing a building. It's a question of going back and forth. So don't think that the design is over, because when you try to implement something that you haven't thought about, it can be the structure, it can be the air ducts, then you will have to change the project, and it happens. So get used to it. Okay, so by default, I can see that you can open this, you can open a mechanical template. There are some, well, we can't load any families. Okay, we have to fix that. By default, in systems, we have mechanical equipment. Let's click on air terminals. Okay, so we do have air terminals. And what do we have? Here we have the supply diffuser, and we have return supply. Okay, good. And then we have a grill. We have grills. Okay, so let's select supply diffuser, and let's put it here. Okay. So this is a supply diffuser, and this is return air. You see the difference? So if we have a supply, we can't connect a supply diffuser to a return air duct. We have to connect a supply diffuser to a supply air duct. By default, we have blue and this pink. Okay, so I don't know if you have the same colors, but for the diffuser, we don't have colors. But if we look at this on a plan, okay, so this is the supply diffuser. We can see the arrows. If the arrows go outwards, that means that this is supply. Let's insert a return diffuser. You see that the arrows are different. We have two things. We have this, okay, so it's a square with two diagonals here, and here we only have a diagonal. So this is return, and this is supply. We are releasing air in this one, and here we are taking air. So if we want to design a building, at least we need a return and we need a supply diffuser. If this is a supply, we have to connect this to the blue pipe or to blue duct. And again, here, even if you don't have colors, if you select this, you have information whether this is supply or return. Okay, let's try to connect this, and let's try to do it in 3D. If this is a supply diffuser and this is the supply air duct, can we right click here, draw duct, and we have to find an active point here. Okay, so you see that when we have something that we can connect, we activate this duct here. We do it, and it doesn't work. Why? Because we don't have enough elements. Okay, so preparing a a template like this, it takes a lot of time just to prepare the template. And what does it mean that we don't have outer root solutions? It means that we don't have the elbows and we don't have the elements that we need to go to this, to connect this duct to this diffuser. And what shall we do? We have to insert things and we don't have those elements here, so we can't load the right handles. Okay, so what if we try to connect this return throw duct? We try to connect this here, so we need something active. So can we connect this here? No, it doesn't work. Okay, so it's not easy. So we have two options. We either upload all the elements, or we use a template in which we have all the elements and we can start working right away. So this is what we have done. Okay, so if we had to work with a default Revit file using systems, we will find that by default, we don't have a lot of elements that we need. So I don't recommend you do that. So that's why I am going to close all this. And that's why I want you to open the template. So I want you to go to downloads. And here we have to open the mechanical template. But don't click on the mechanical template, right click. No, sorry. Don't double click here and open Revit because we have to open this mechanical template as a project. So we have to go to new, and now the template file is not something that it's by default. We have to browse in our computer and in downloads. Where is it? Where will we have the downloads? Downloads here. And well, I have downloaded the same mechanical template. So I opened this mechanical template. And now I open this as a project. And well, it was in 2022, but we can upgrade it to 2023. Okay, so there is a blank file, but on this blank file, I'm sure that you can, if you go to, well, first let's check the discipline. The discipline by default is coordination. Change to mechanical, because we are going to deal with mechanical systems now. And now go to systems and mechanical equipment. And you will see that there are a lot of things that we can. Okay, so I have uploaded a lot of elements, and I think I have most of the routing solutions with elbows, T's, and all that stuff. Sometimes if we try to do something, we might have the same warning. We don't have enough routing solutions to do this. So you can either find what you want and insert it, or you can change your design. So this is up to us. If we want to work trying to find what we need, go ahead. Otherwise, we have to work changing the original design. So both times you have to work. Okay, so it's not that, okay, this is the easiest and the hardest. No, this is tough. Okay, but I think with this template, you can save a lot of time, because there is no time So there is no point in wasting your time as students or as human beings. Try to find, okay, so I need this elbow and it's not here. So I have all these options. Where's the fucking elbow? I can't find it. So I think here you have a lot of help with this. Let's work with the air handling units, because I showed you what an air handling unit was on Tuesday. And here we have the right air handling units. We have these horizontal. Usually those big monsters are horizontal. So here we have different sizes. Okay, so if you select the smallest one, the 6 square feet coil, it's here. And if we select the biggest one, the 61 square feet, we have a bigger monster. Okay. So on the 3D view, okay, so we have this. So that depends on the size of the building. It depends on the airflow. The bigger the building, it's not a question of the dimension of the building, it's the amount of people. Usually, the bigger the building, the more people we have. But if we have a very small building with a lot of people, we might need a very big mechanical air handling unit. Okay. Anyway, we will calculate the airflow that we need, and then based on this airflow, then we have to decide what kind of machine we are using. But you see that there's a difference. Okay. Let's work with the smallest one. And let's click here because here we have a lot. It's much more complicated. Well, much more. It's complicated than the other one that we were working with. Okay, so now we are familiar with this. We have inlet, and we have outlet. Okay, so the outlet, when we right click here and draw that from the outlet, what is this? By the way, do we have colors here? In this case, do you have colors in your computer? You do? I don't. Well, anyway, if we don't have colors, you have to click here, and this is supply. So everything that comes out is supply air. Makes sense, because it goes from the air handling unit to the room. If it's inlet, it goes from the room to the air handling unit. Okay, so this is outlet, and the other one is inlet. Outlet is supply. Inlet is return. Okay, so this is supply. Can we draw that something like this? Yeah, we can. If we want to go downwards, then we have to change the elevation. The default elevation here is 1 foot and whatever. If we want to go downwards, here we have to type a negative number. So let's type -20. We go downwards, and we don't have a routing solution. Interesting. Okay, so we can't go downwards. Okay, because we don't have the right elbow to go down. We will find it. Don't worry. But anyway, there's something that we have to do. Somehow we have to connect this. So here we have an active point, and here we have another active point. Okay. We can always drag this and we can change the direction. So by clicking on this active point, we can change the length of this. So let's try to do this. Let's try to connect this and this. So I'm going to click this, draw that, and I want to click on this point. Does it work? It doesn't. Let me try something different. Draw flex duct. Okay. Okay, flex ducts are great because we can do these kind of things without the constraint of. Okay, so using flex duct, we can connect these two points. And now, if we select this, this is supply. If we select this, this is supply. If we make a mistake and we insert a return air duct, then it won't work. And it won't work because now we have to calculate things. So first we have to design the layout, and then we have to calculate the airflows, and then we have to calculate the size of the ducts, the speed of the airspeed in the duct. So it's not just a question of designing the layout and okay, so I have connected the air handling unit to a diffuser. That's it. No, that's the beginning, and then we have to check all the parameters that when I was student I had to calculate by hand. And then, okay, so what's the size of this? If the size of this is 12 by 12 inches, the airspeed has to be, I don't know how many feet per inch. And then it was a nightmare, okay? The airflow is this, but here you have all this information. If you click here, you have the airflow. We have not considered any airflow here. You see that it's 0, but you see that we can change it. Okay, so the airflow is the amount of air that we need in that room. So we can change it anytime, and we can do this, and then we have information about the velocity or the airspeed, and we have information about the size. This is the width and the height of this duct. Okay, so we need these three. So first, we need to make sure that we are working with supply or return, and all supply ducts have to be connected. If we connect a supply duct to a return duct, sometimes there is a warning, sometimes there is not. But we find out that we have done something wrong when we check the calculations, and we start we see like weird numbers here. What is this? A negative flow or what's that? So when you see things that are not working well, usually Revit has a warning. You have connected a supply and a return duct. Oh, we can do that. But if you don't have a warning, then you have to find out that you have done something wrong. Anyway, let's insert a diffuser. But to insert a diffuser, I don't know, let me see the levels. Okay, so by default, we are here, and we are going to insert, we have level 0 and level negative 15. Okay, let's try to insert a diffuser on level 0. Oh, but here we were in level 30 by default, and I have inserted this on level 30. But well, that makes sense because this can be on the roof, and then on level 0, I need a diffuser. So let's open level 0. And if we open level 0, the problem is that we don't see where the air handling unit is. What can we do? We can work with the view range, and the top, let's make it unlimited and see what happens. Okay, so now we see where we are. If we see only wires, we have to click on fine detail, and now we see the thickness. Okay, we are on level 0 now, and we have to connect this duct to a diffuser. And the diffuser has to be, well, that's another thing. In this case, we don't have diffusers in this room. Well, we have grills. This is a grill. And here with this air duct, we have these perforations. If you want this, I'm sure you can find a Revit family with this kind of pipes, and there will be an element that it's something like that. So with this, you don't need a diffuser connected to the duct. So here, diffusers and the duct is the same thing. Here we have a grill, and there's something above the false ceiling that is connected to that grill. So there's another duct, and we don't see that element. No, we don't see that element. And do we have any other diffuser? Well, we have grills here above. Well, for some reason, in this building, we don't have a square diffuser, which is the most common thing in mechanical systems. And this is when we click on air terminals, by default, well, we have more things here. We have supply diffusers, we have return diffusers, and we have exhaust grills. Supply, it's something that supply and return, it's they are always connected to the air handling unit. The exhaust is something that we need from, for example, from the kitchen. If you have ever cooked, you have found that above the fire, we have something that extracts air. You click something and that's the exhaust grill, because it's not connected to anything. Basically, you extract something that you can't breathe anymore, because it's something that comes from frying bacon or whatever. So you don't want to include or to introduce this air in your air supply system. Sometimes it happens, there's a mistake, and if you are in the same building where a restaurant is on the ground floor, on the third floor, it smells like bacon or whatever. Well, because there's something that it's not working well, and you are somehow you are mixing exhaust air that you have to get rid of with the air supply. When that happens, it's a huge mistake. Okay? But we need three kind of grills or diffusers: supply, return, and exhaust. We are working with supply. And here we have different sizes, 12 by 12. The square is 12 by 12. And the neck is this round or this circle. So that's the neck of the diffuser. So that means that you have a 6-inch neck. Usually we go, so the first duct here is too thick, and then we have different branches. So when we branch out, the things are getting smaller. So at the end, we can have, if our last duct is 6-inch, we would use this 6-inch neck. If it's 8, we would use this one, or 10 or 12. Let's use a 12 neck, and let's place it here. Okay. So now on the 3D view, we have to make sure that the diffuser it's at a lower level than the duct itself. And let's click here and let's draw duct and click here and see what happens. We don't have the outer root. When the outer root is too complicated for straight lines, it doesn't work. So if it doesn't work, I would use a flex duct here. And there you go. But you see that Revit is great, because we have this transition element. We don't have to, this is a round to rectangular transition element. And it goes from this size, 44 to 37 to 12 inches. Revit is amazing. Okay, so Revit understands that we need a reduction. This is not a good design. We're just testing Revit, but we can't go from 44 to 12 with one element. Doesn't make any sense. Okay, but anyway, if the root doesn't work with straight elements, it will work with flex ducts. Flex ducts are usually more expensive than the others, but I would use flex ducts only for the final duct to the diffuser. I wouldn't use flex ducts here. Okay, so if this doesn't work, I would I have to find another design, another layout to make it work. Because here we don't have a building, but imagine that we have a building. So this is the room, this is the air handling unit. What's this? Okay, so we can have a duct doing in the middle of a room. Anyway, so far we're just testing Revit. So we go from the air handling unit to the supply diffuser. The supply diffuser always has a flow. You see that we have a flow, it's 500 CFM. So now immediately, if something is connected to the flow, if we click here, the flow is 500 CFM. If we click here, the flow is 500 CFM. And if we click here, the flow is 500 CFM. So this is what we have to check. If for some reason we make a mistake, imagine that we don't have this element, the flow here is 0. So this is how we can check if there's a leak or something is not connected. Okay, here I can see that it's not connected for sure. But sometimes you can't tell because you do something like this and well, you don't notice that there's a gap here. If there's a gap and you click here, the flow is 0. If you click here, the flow is 500. So, and if you click here, the flow is 0. Okay, so if this is 500 and this is 0, there's a problem with this elbow. Can you fix it? Yes. So if you find out where the problem is, then we can fix it. And once we have fixed this, now this is 500 again. In terms of design, if there's a gap, it doesn't matter because if I'm the architect and I'm designing the layout of the ductwork, it doesn't matter. But if we have to calculate it, it matters a lot. Okay, because at the end, we have to find out the total airflow and the airspeed. And well, there are different parameters that if things are not well connected, we will make a mistake in the calculations. What if we have different branches? So imagine that we are on level 0 and we have 2 different rooms and we need 2 supply diffusers. So I'm going to insert another supply diffuser here. Can Revit connect this to this? Let's find out. Right click, draw duct, and we need to find an active. This is not active. If we do this, it doesn't work. So the active is this line that we have in the middle. You see? So sometimes we can do it. But if this middle line doesn't show up, it means that we can't do it. Because if we do this, okay, so this is something it has. We have split this, and what do you need here? We need a T. Okay, so if there's a duct, and then we have to continue the flow in this direction, and then we have to go in the other direction. This is not an elbow. Elbow, it's something that doesn't change the total airflow. But with this, we need a T. Do we have T's? Okay, so we can go to systems, and we can go to air terminals, flex ducts. This is the fitting. Duct fitting. Yeah, I didn't find it. Okay, so here we have ducts, and here in this computer we have the duct fitting here. If we click on duct fitting, we have elbows, T's, reductions, well, different things. So by default, we have a round T. Do we have a square round T? Well, there are a lot of things. Let's use a standard round T and see what happens. Okay. There is a T. You see that a T, it's something that has 3 inlets or outlets, 1, 2, and 3. So the third one is here. But if this duct is going downwards, we have to rotate this T. So probably if I click here, this rotate Okay, it goes up, but now I know what to do. Now I have to rotate it until it faces down. And then if this faces down, can I drag this here? Yes, I can. Okay. And now finally I have to connect this. Can I connect this active point to the active point? Cancel. I try to connect this somewhere. It doesn't work. What if I select the T and draw that up to this point? Doesn't work. Okay, so you see that things are not getting easier. Is it easier if I turn this into a round duct? Will this connection be easier? I can't find the active point there. Shall I use a flex duct? Yeah. See. So we have T, but it's a bad design. It doesn't make sense. Okay, so we don't go from round to square or rectangular, and then it doesn't make sense. So we have to either, are we working with round ducts? Go ahead. Are we working with rectangular ducts? Okay, go ahead and use flex duct only for this. Okay, so we're not designing this very carefully. It's just we're exploring, but this is not a good design. So don't feel proud of this. But what we have to check now, we have two supply diffusers. This is 500 CFM, and this is 500 CFM. So here, if everything goes well, if everything is well connected, the flow in this pipe or in this duct should be 1,000. Is it? It is 1,000. Okay. So that the connection is good. The layout is terrible. Okay, but at least we make sure that everything is well connected. Okay, so we are in systems, air terminals, and I want to place a supply diffuser. So let's do that. And if this is the inlet, probably if I place supply diffusers here and here, they are on level 0. These are the return diffusers. Sorry. And then somehow I have to connect these two diffusers to this. You see that here we have two inlets. We have inlet and inlet. This is because in this air handling unit, remember that we need a heat recovery. So the heat recovery, we need to insert the return air. Then we have the supply air from the outside, the fresh air. Here we have the heat recovery, and then we go through this. I will explain what this is later, and then we go to the supply. So which one shall we use? Either this one or that one? I don't know. Last year I found out, but now I don't remember which one I had to use. Okay, let's use this one. But the goal is to, with the minimum amount of ductwork, because that's another thing. The layout is good when we are using the minimum amount of work of ducts, because it's expensive. Okay, don't do crazy shapes or don't do a curve like this. Oh, it looks beautiful. No, it has to be straight, and the shorter the distance from the diffuser to the air handling unit, the better. It's not just something about, it's about efficiency, It's about we save energy, because if the duct is too long, then the fan that moves the air, it has to be bigger, and it consumes more energy. Okay, so we have to minimize the ductwork. So if I have the air handling unit here, and I have the diffusers there, so minimizing the ductwork means the ductwork means that we have to place a horizontal duct here, then we have to go vertical, and then we have to do this. Okay, so now we're going to design this layout, minimizing the ductwork. Here, I didn't pay any attention to that, but now I want to minimize this. So if I want to minimize this, if I'm on level 0, so I have to go from this to this air handling unit. I can work with ducts, but now I'm going to work with round ducts, because it's easier, and I think it's more beautiful. It's more expensive, but anyway. So if we're working with round ducts, we are on level 0, and here we have the elevation. Well, I know that if I want to connect this diffuser to the duct, the elevation of the duct, in this case, the duct has to be above the diffuser, so that I can use a flex duct. So let's do this. So the elevation here is 0. I'm going to move it 2 feet up from the diffuser level. And then I will do this. Okay. On the 3D view, we can see that the duct is above this. This duct is too much, so I'm going to reduce the diameter. It's 44 inches. I'm going to use 20 inches. Okay, so that looks better. And so, well, I show you that you can change the size of diameter anytime. And now I'm going up, but make sure that this is a supply air. Okay, so I made that mistake. If I connect, this is a return diffuser to a supply air, what happens? Can I do it if I draw a flex duct? I can. So there's no warning. I have a supply air connected to a return diffuser. So in terms of how can I find that I did something wrong? Because the flow here is 500, the flow here is 0. And the connection is good. The problem is that I have connected return to supply diffusers. So it's very easy. Making this mistake is very easy because there is no warning. But the flow is not working. Here we have 500. Here we have 0. The connection is good. There is no gap. But this is a supply, and this should be a return. So let's do this. Can I change this? Yeah. So we don't have anything connected. I can change this to return. And now when this is a return pipe or duct, I can connect this with a flex duct here. And this is 500 and this is 500. Okay. Now, can I connect this directly to this? Okay, that's interesting because now we have this line highlighted. So if I have this, I can do it. Click and connect it. But Revit is great, but this is not what I wanted. Okay, so what's the point? So I can delete the flex duct, but now I have the T, and I can rotate it, and that's the right position. Okay, so now I can draw a flex duct here. Well, let's try the other way around. Oh, well, by default, something has appeared. We have this reduction or this transition round to rectangular, and we have to get rid of it as well. And then we have to start. Right click, flex that here. And now it works. Okay. So we're doing good. And now I'm going to use the top view. And from the top view, if I want to minimize this, I can drag this and Revit again. It's smart. So when we are in the same vertical, we have this highlight. Perfect. And now from this, I need to drag another duct. And when we are here, something will activate. Okay, so we can activate this point. You see? And life is wonderful. And things are working. Amazing. So again, if we want to check that everything is correct, this is 500, this is 500, so this should be 1,000. But no, this flow is 0. This is 500, so that's good. So there's something wrong here. What is it? This is return. This is return. This is 500. I have done this. This is return. So why isn't it working? I don't know. Let's drag this. Okay, so there's something wrong in this connection, and it's something wrong because it's not natural. So we can't go from a rectangle to a circle. It doesn't make sense. Let's do it again, and now let's do something better, okay? Because now it works. This is 1,000, and this is 0. Oh, this is 2,000. Well, I don't know. But this is wrong. Okay, so let's delete all these. So the problem, I think, here is that we have that rectangle, and then we have to connect a rectangle like this to a circle like that. Doesn't make sense. So I'm going to edit the outdoor air handling units, and I'm going to edit the inlets. So we can edit type. And here, the supply inlet, we have 4 of them. So I'm going to make it square. Okay, so I'm going to make it, let's say 20. So all the inlets are going to be 20 by 20. Apply and okay. Okay, now this looks better. If we are working with this size, that looks better. Okay, so by default we have this rectangle, but I think that will work better. And now if I draw that from this, go. And now from the top view, if I just connect these 2 ducts, the transition will be much better. Okay, that makes much more sense. Can I make it even better? Yes. So I'm going to turn this into a round duct. So if this round duct is 20 and this round duct is 20, now the transition will be even better. There you go. Okay, so we are minimizing things. If we have transitions from square to round, and then an elbow, and then a reduction, we are introducing a lot of potential malfunctions in the system. So so this layout, it looks something feasible. This is crazy. Okay, so it doesn't make any sense. But this, it's much better because we have reduced the length of the ducts, and we have reduced the transitions, round to square, reduction from 40 inches to 20 inches. So we have to do that. Eventually, in big buildings, we have a lot of reductions, elbows, T's, all that stuff. But if we reduce the amount of things that we have, it's a better layout. So it's about simplifying things. So this works. Yes, I have connected supply diffusers to the outlet. It works. Okay, it's not enough. This is much better. Okay, are we done with this? Not yet, because remember that the air handling unit is a device that has air ducts. So we are focusing on air ducts because it takes up a lot of space. But remember that we had filters, coils, okay, and here we don't have filters because a filter, it's something that is not active. So it's something that it's a screen that it's there. We have air and it filters particles. But we need active elements. And what are the active elements? The coils. So here you see that we have the heating and the cooling coil. What's the heating and what's the cooling? Good question. We don't know, but oh yeah, we do know. The cooling coil needs drainage. Okay, so here in this air handling unit, we have two coils. We have this one and this one. The one with the drainage is the cooling coil because condensation can happen in cooling coils. It doesn't happen in the heating coil. So when we have a drainage, and then we can do the same, we can draw pipe. So this is the drainage, and we have to connect this to the drainage system, and that's the cooling coil. So there's an outlet, draw pipe, and there's an inlet, draw pipes. So that's the cooling coil, and then we need to connect this to the cooling system. So there will be something that cools water, and this is the heating coil, and we have to connect this to the heating system, so something that heats water. But you see that working with pipes, it's a lot easier because we can easily, and then we change the elevation, -20. So it works the same. Okay, so it's the same working with the ducts and pipes is the same, but the space, we can run pipes anywhere, but ducts. Okay, we can run pipes anywhere, but we can't have a pipe yet here in the middle of the room. But if we want to have a branch, a horizontal branch, and then to make it close to the wall, it's easier. But with ducts, yeah. So we start designing the layout of the ducts, and then we design the layout of the pipes because the ducts are more demanding. Okay, so you have used this template. So in that template, we have a lot of things. Do we have all we need here? No, probably sometimes we will need to upload another element or to insert another element. There are thousands of websites with MEP Revit files. Okay, so as you can see, you can find on the internet anything you need. And most of those websites are for free. You have to register and they will send you whatever information, but you can register for free and you can download or upload on your drawing anything you need. Okay, so there are a lot of families. So if you're looking for a specific thing, you can find it on the internet. This thing, by the way, if you go to mechanical equipment, most of the things are default in Revit, but I found this on the internet, and this is a split system indoor unit. So this is exactly the same thing that we have downstairs. Well, it's the same thing that we have here. So this grill is connected to the split indoor unit that is above the ceiling. But I didn't find this in Revit, and I uploaded it from one of the websites. And if you click on it, we have inlet, we have outlet, and we have for air ducts, and then we have drainage and inlet and outlet for pipes. So all these elements have the same, and then we have the electricity here. Okay. But all these elements are alike, and they all have air ducts and then water pipes or fluid. Well, this is a split system. This is not water. This is the fluid, the refrigerant fluid that we spoke about on Tuesday.